Hi, everyone. Welcome to this first event in our online series on responsible reporting, responsible science journalism on technological solutions for climate change. My name is Olga Dobrovidova. I used to be a science journalist in Russia, then a science communicator for a while. I was the first vice president of the European Federation for Science Journalists, and now I work in a non-profit comms shop, helping people tell and hear, coherent stories about science and have informed conversations about science related to climate change. And I'm going to just be very, very brief with my introduction because I can't wait to give the floor to Rebekah, who I'm very honored to have as our first speaker in the series. It is, I strongly believe that once upon a time, maybe years ago, it was on science journalists to establish the physical foundations, the fundamental science of climate change, and this was the age of stories that yes, climate change is real. No, it's not a hoax. We're unfortunately somewhat still in that age, but it's no longer about science and about science journalists. It's a deeply political conversation. Now, science journalists, in my view, have a different responsibility, which is to help our audiences understand these technological solutions to climate change. Whenever someone is claiming that science is going to help solve the climate crisis, I believe science journalists need to be there to interrogate that claim in the interest of our audience. That is why I was thrilled to learn that Rebekah, who's a Reuters Institute for the Study of Journalism fellow, actually wrote a white paper, a fellowship paper that all fellows do, on the non-scientist guide to reporting on climate repair. And I'm going to let her explain what she means by climate repair. I'm also very, very thrilled that that paper is now online. I'm going to drop the link into the chat in just a second. Right, this works. So you can have a look. We're going to cover the basics of it, but obviously, if you have more questions, we'll have more events, maybe with Rebekah as well. And it's worth acknowledging that we're right in the middle of COP30 in Brazil. And as we were just talking before this call, it's actually not looking that great for climate repair and for climate ambition. That conversation is complex, but the outcome is, I mean, in a sense, it does put more pressure on journalists to explain what's been going on with climate solutions and high-tech climate solutions. So with that, I'm going to pass the floor to Rebekah. Go ahead. The floor is yours.
Hello. Thanks for joining me at this weird time for a topic that probably doesn't sound that exciting, but I'm really excited about it because I think it's an area where journalists have a lot of power to shape and direct public conversations. So I'm just going to share my screen. I hope you'll ask questions along the way. This is sort of like a forum for figuring out how we all do this. Let me just figure out. I did share my screen just before, but we're going to do it again now. Okay. All right. Hopefully you can see that, and hopefully I can see my notes. Here we go. What is climate repair? A very good question. You can call these technologies lots of different things. Basically, it's an umbrella term for a bunch of quite unrelated technologies that are all trying to stop the world warming up so much that ecological disaster occurs. You can call them climate engineering, you can call them climate interventions, climate solutions, you can call them geoengineering. You can make them sound better or worse depending on which words you choose. And that's one way that we have a lot of influence on how these are presented. I'm going to talk more about that later. But this talk's going to cover these three big questions. What are some of these technologies? What are the problems, issues, challenges with them that you might want to ask questions about as a journalist? And what are some ideas for reporting on them? Because I think that these technologies are a bit special and need a bit of extra sensitivity. And I am going to start by telling a story that illustrates why that's the case and also looks at the role of journalism in all of this. So, this is a very cute town on the coast of England called St. Ives. And about 3 years ago, the people living here heard something pretty weird. They started hearing that a Canadian startup company was going to tip a chemical into the sea off their coastline right here in an attempt to change the pH of the seawater, to make the seawater less acidic. And then if that worked, then that was going to help reverse climate change, which sounds kind of ludicrous. And at first, people thought that it was a joke or a really bad rumor. But in fact, it was all true. And then it sort of kept getting worse the more they heard about it. The chemical came from mining waste from somewhere in China. And people were really confused about this. They were like, we have mines at home. We've got mining waste around the corner. But mostly they were really worried about whether or not it was safe. And the company was like, of course it's safe. We're just going to do it a little bit. And people were like, how do we know? And sadly, the journalistic coverage didn't really help. There were a couple of stories about it, but they kind of just put the townspeople on one side saying, we're worried, and then the company on the other side saying, don't worry, it's fine. And there wasn't sort of any appeal to any form of independent expertise to establish the facts, or even to take the community's concerns to someone that they did trust in order to address them. In fact, this idea that the company had is completely legit. It's a carbon dioxide removal idea. It's called ocean alkalinity enhancement. If this diagram makes sense to you, this is a very quick overview of how it works. And in theory, it can soak up a lot of carbon dioxide from the atmosphere. But at the time, it was so new that people couldn't even Google it. There was just nothing that they could learn. And this was going to be one of the first ever real world tests of it. Um, the company itself, they sound like the baddies, but they were trying to do the right thing. They knew that there wasn't any oversight of what they were doing. And so to compensate, they published their methodology online, which is commercially sensitive information. It could have hurt them to do so. They didn't have to do it, but they were thinking, oh, maybe others in the field can provide some scrutiny. Nobody did that though. And this is the actual beach where they were going to do it. It's just around the corner from the town. And eventually the British government did do an environmental audit, and they said, yeah, it's safe. You can try it. But it doesn't really matter how safe your test is if everybody hates you. And once you lose public approval, you don't tend to get it back again. So in the end, the whole thing was called off. This story in Hakai is a good summary about the whole thing if you're interested. But basically, this whole saga encapsulates the challenges in researching and communicating about these technologies. If we want to find out whether or not ocean alkalinity enhancement works, then we have to conduct some real world tests somewhere. And we're never going to be in complete possession of the facts about whether it's dangerous or not because it's completely new. We're going to have to make these decisions about testing or using these technologies based on risk probabilities, which means that it's not really a scientific question whether we do it or not. It's a social question and one that the public should be involved in. So in the future, I think we're going to need a lot of public conversations about whether or not to do these kinds of trials. And this is where journalists come in. I think we've got a really big role to play in terms of setting the scene for good public conversations about technologies like these. And so when I visited this town and talked to people, I left thinking, well, if a project is going to get cancelled by the public, it would be really great if it got cancelled because it was actually a bad idea, not because of conspiracy theories, which was happening a lot here, or a company communicating badly and losing trust, which also happened here, and things like that. So this is the point I'm coming to all of this from. I started thinking about what the responsibilities of journalists are in talking about technologies like this, how we can help, for instance, in terms of just stopping people feeling anxious or providing a forum for allowing their concerns to be addressed. And the reason I find this whole subject really interesting is because it's not possible to say at this point whether any of these technologies are good or bad. They're going to be appropriate in different circumstances or locations or under different governance structures. It really matters who's funding them, who's profiting from them, who deals with the downsides. And so there's so much nuance and difficult context to get into journalistically. Anyway, so I'm going to talk about two really big areas of research, carbon dioxide removal and solar geoengineering. These fall under the umbrella of your climate solutions. I'm actually going to present them like this because they're really different technologically, but face some similar issues in terms of how we write about them journalistically. Maybe don't tell any climate scientists that I'm talking about them at the same time because they're usually held quite far apart. But very quickly, carbon dioxide removal is about sucking carbon dioxide out of the atmosphere. And we have to do some carbon dioxide removal if we're going to meet any of our climate goals of limiting warming to 1.5 degrees or even 2 degrees. It's necessary. On the other hand, solar geoengineering, it doesn't address the root. It doesn't address what causes climate change. It's about trying to reflect sunlight so it doesn't do so much warming in the first place, like by making clouds or putting little particles into the atmosphere. So it's optional. It delays the impacts of climate change. If that sounds like a bad idea to you, you're not the only one, but it's being pursued because it might help prevent some irreversible damage happening to certain ecosystems while we sort of sort ourselves out on the emissions front. Speaking of, I have to point out that neither of these technological fields work unless we stop putting so much carbon dioxide into the atmosphere in the first place. If we don't reduce emissions very quickly and dramatically, these are just not going to be helpful at all. They're basically like they're add-ons or they're expansion packs. They don't work without the base game, which is emissions reductions. When I say that carbon removal is necessary, though, people are often skeptical. And I think they're skeptical for two reasons. And one is because it didn't used to be necessary. But we've missed all of our climate targets, so now it is. A good illustration for that is the biathlon, my favorite sport, is the skiing and shooting race in the Winter Olympics. Climate change is the biathlon. Every time we miss a target, like the shooters do, we have to do a loop of a whole other penalty course, which is carbon removal. The more we miss targets, the more carbon removal we're going to have to do just to get to the end of the race. And the other reason people are skeptical about carbon removal is because they're confusing it with an industry with a similar name, which we will get to. But don't believe me that it's necessary. This is from the IPCC's 2022 report, which was the first time that the IPCC said, okay, things have gone too far. We definitely need carbon removal now. So carbon removal is now going to be part of different countries' national climate goals. And so you'll be able to investigate what kind of carbon removal your country is planning to do, and whether you're going to do it yourselves or buy some carbon removal from somewhere else. All right. How do you do carbon removal? We've thought of lots of ways. Some of them work. We don't know if all of them do, but you can plant trees, you can grow kelp, you can grow whales, you can grow phytoplankton, you can store it underground, you can burn wood in a low oxygen environment and then bury it. You can vacuum it out of the sky. This is a pretty diagram, but this one's actually more useful. It looks a bit complicated, but it actually starts to make sense the more you look at it. And this one also tells you about some important features of different carbon removal techniques, including how long does the carbon removal last for? Because if you plant a tree or forest, great, everybody loves trees. But if there's a forest fire, you lose all of your carbon storage, and also trees don't live forever, so they will release their carbon at the end of their natural lifetimes. So there's different timescales involved, there's different security levels of storage involved. But mostly I would like to draw your attention to this yellow column, which categorizes these methods as either conventional or novel, which basically means we know that they work and we don't know if they work. And you might say, why don't we just do the ones that work? Which is a great idea, but those ones are very slow. It's literally waiting for trees to grow. And they also take up a lot of space. It's not actually possible to plant trees to solve all of our carbon removal needs. We do keep pretending that we can. This is a non-profit which tracks the amount of land pledged to forests for carbon removal and how we've actually pledged too much. So we've calculated that we do actually need to use some of the new methods of carbon removal, and that's why these ocean technologies or these new methods like ocean alkalinity enhancement are being trialed. I'm going very fast through this, but all of this is in my paper if you're really keen and want to learn more about it. If you're investigating a carbon removal project, what do you want to know? You probably want to know this. How do you know when you've removed some carbon dioxide? And this question is actually very hard to answer. Carbon dioxide is invisible, but it's also central to the industry in question. And the difficulty is we don't understand a lot of systems quite well enough to be sure. And this tweet really illustrates an example of that. For a while, there was a series of papers coming out saying the Southern Ocean was more or less of a carbon sink than we previously thought, which prompted the scientists to be like, come on, Southern Ocean, make up your mind. What are you doing? But it's just an illustration of how hard it is to understand how some of these systems work. And it's the same with forests. Understanding of how much carbon dioxide is stored by forests and how long for and how quickly is not particularly settled. It depends on the forest and the location and the composition. It's just not as straightforward in the way that a carbon accountant really wants it to be. So there's another industry that has sprung up in order to check companies' carbon dioxide removal claims. It is called measurement, reporting, and verification. Because if a carbon removal project is good, they probably realize that they don't want to mark their own homework. They have to go to an independent authority to do the measuring. At this point, governments are not set up for this. This isn't a public sector thing. Rather, there's a mix of non-profits and companies that are specializing in doing this for different carbon removal methods in an attempt to provide some oversight. One example of an organization that you could talk to is the Carbon Removal Standards Initiative. This is a non-profit that's been set up by a scientist turned climate activist called Anu Khan, who's a really great communicator. And this is looking at whether carbon removal projects are being measured in the right way and by a reputable agency. The other important thing that you probably want to know about a carbon dioxide removal project or about research is, can it scale? And this is the tree problem. A big question is whether a project is scalable so that it's possible to actually remove really big amounts of carbon dioxide, or whether it's going to hit some hard physical limits like available land area, or in the case of kelp as a carbon dioxide removal solution, available coastline. You actually can't grow it everywhere in the ocean. So can you do enough of it to be meaningful? And this is why the ocean-based methods are really exciting, because the ocean is really, really big and can store a lot. So if those methods work, they're really promising. But this is kind of the problem that these direct air capture facilities face, because they're often criticized for being expensive or inefficient or not working, as the case of at least one. And I think there's a delicate boundary here in terms of thinking about scalability, because there's a difference between actual physical limitations, like how much land you have, and then technological or financial limitations. Because just because something doesn't work now doesn't mean that there's a limit on it working in the future. There's not that hard boundary as there is with coastlines, for instance. We're going to come back to this kind of technology. But the other really important thing about carbon removal is that it is always mixed up with carbon capture. And who can blame anyone? They sound exactly the same. In fact, they're completely different. And the way to think of it is that if carbon dioxide is pollution, then carbon capture is stopping the pollution from going into the sky, and carbon removal is cleaning up the pollution that's already in the sky. So one doesn't change the amount of carbon dioxide in the atmosphere, and one does. Also, carbon capture has had a lot of fraudulent, scammy, bad faith activity happen. So when people are skeptical about carbon removal, I wonder if they're actually thinking of carbon capture, which has had a lot of bad press, justifiably. Um, anyway, bear with me for a minute because it gets worse. So this list of things, these are a list of carbon capture and carbon removal technologies. Some of them are one, some of them are the other. Can you tell the difference? Is this the world's most boring pub quiz question? I think it might be. Here's the answer. Like, this is ridiculous, right? Like, how is anybody supposed to understand which is which? And maybe this sounds like a minor quibble, but the problem is that you end up with headlines like this, which is asking if carbon capture is a good way of tackling carbon dioxide, but actually it's a story about carbon removal. It just gets really confusing. No critique to the journalist here. We don't write our own headlines. And I think the only solution really is to ditch the industry's jargon entirely and not use it. You don't have to use their language. I think you're on the right track if you're using words that the industry doesn't use. And it takes longer, but it makes more sense. So now I don't usually talk about ocean alkalinity enhancement. I talk about storing carbon dioxide in seawater molecules, which is what that is. I don't really talk about MRV. I talk about independent assessments of a company's carbon removal claims. If you're not writing in English, I wonder if you have an advantage here because maybe you get to define the terms. I'm interested to know if that's the case. That's carbon removal in a nutshell. If you want to know more, these reports are a good starting place. They're designed for policymakers and politicians, so they're actually quite readable. But let's take a quick look at solar geoengineering and then talk a little bit about how we cover these. So, solar geoengineering keeps popping up in science fiction, and it's a little bit controversial. It's had a lot of bad press over the years, and the most important thing about it is that it's not necessary in that it won't help us fix or address the root cause of climate change. We're also still very early in studying it. The concept of a lot of solar geoengineering is put some particles into the sky so the sunlight bounces off them and doesn't warm up the world as much. And we know that this works in theory because it's happened before, but we just haven't tried to do it ourselves intentionally. This is a picture of two forms of solar geoengineering happening in the present day, or a couple of years ago. You can see in the sort of brownish area, that's a volcanic eruption that's put some sulfur dioxide into the stratosphere. This one probably not enough to measurably cool the planet, but volcanoes have done some planetary cooling before, especially in 1815 and 1991. And more recently, we've also been creating clouds over the sea with pollution from ships. So when new regulations came in a few years ago to stop ship pollution, the regulations were really effective and less particulate matter came out of ship smokestacks, created fewer clouds, and that ended up actually having a warming effect because those clouds, those pollution clouds, were deflecting sunlight. So we know that these things work. We don't know how to control them. We don't really know how to do them ourselves, and we don't know what the flow-on impacts of them are. So people are understandably nervous, but there's a lot of debate, which we will talk about just now. These diagrams are from this Royal Society report that came out a couple of weeks ago, and this is a really good summary of where the research is at and what the boundaries of our understanding are. A good place to check people's claims about what's possible, because there are a lot of solar geoengineering arguments right now. And unusually for science, there are calls not to study it at all, which is a little strange. I don't sort of notice this happening with many technologies. But to whiz through them, a bunch of scientists have signed this open letter calling for no research or use of solar geoengineering. A different bunch of scientists have signed this open letter calling for more research of solar geoengineering. Or this open letter calling for balanced, moderate research into solar geoengineering with a few principles in place. It's just like open letters all over the place here. And then recently there've been a flurry of arguments that were prompted by this paper, which is titled Safeguarding the Polar Regions from Dangerous Geoengineering. Really gives away how they feel in the headline. And this contains a number of critiques of solar geoengineering, which have also been criticized. But those critiques basically boil down to these. Moral hazard is the idea that we might take on more risk because we think we can sort out the consequences. So the idea that we won't reduce emissions because we can just use solar geoengineering to sort it out. But actually, some research shows that the idea of having to do something like solar geoengineering makes people more interested in reducing emissions because they're like, that's scary and difficult. Number two, is it going to take resources and money away from efforts to reduce emissions? The dangerous distraction argument. That's the one mostly made by the paper that I just showed you. Currently, we spend very little money on solar geoengineering research at all. So I haven't found good evidence for this argument of actually it taking away from money that might otherwise have been spent on decarbonisation efforts. Number three is the slippery slope idea, the idea that we shouldn't study it because if we know how to do it, then we will definitely end up doing it. We won't be able to stop ourselves. And this is a very popular idea. Other scientists have pointed out that there's plenty of examples of technologies that we don't use, including some solar geoengineering, or in fact, carbon dioxide removal technologies that people developing them have actually stopped because they looked at it and thought, oh, that's actually dangerous, has some bad side effects, let's not do that one. And then the last thing is people pointing out, how would we agree on how to do it? This crosses borders, it can't exist within the jurisdiction of one nation. We don't have a governance mechanism for organizing who makes the decisions. And that's right, we don't have a way of figuring out how to do it at this point. We will need one if this is a technology that people decide to go ahead with. I just want to talk about quickly the question of banning solar geoengineering research, because there are quite a few efforts to ban research in different US states at the moment. But it's a tricky thing to ban because in reality, it's pretty indistinguishable from other research we would do to understand atmospheric dynamics. So if you ban solar geoengineering research, you also ban accidentally a bunch of meteorological or atmospheric research. To show you an example, this is what solar geoengineering research looks like. This is a project on the Great Barrier Reef that's attempting to make clouds brighter, with the idea that when there is a coral bleaching weather event forecast, hopefully the idea is that these ships will be able to go out and spray. What they're doing is spraying really, really tiny salt particles into the clouds. Those tiny particles attract water vapor. They make the clouds bigger. The clouds bounce the sun off them, and then hopefully you stop the coral on the reef bleaching out of extinction. Interestingly, this project, unlike the St. Ives one, has really high public support. That might have something to do with the scientists talking to everybody about the project right from the outset. They also have permission from the Indigenous peoples whose sea country the areas of the reef are that they're using. So it's an example of a different way of going about things from the beginning. The other consideration in banning solar geoengineering research is that if a baddie decides to do some on their own in an unsanctioned way, do we want to understand what they've done and what the impacts might be? And we already have some of those. These are some rogue solar geoengineers. It's a startup company called Make Sunsets, who are basically like climate tech edgelords. They have been conducting illegal tests. Basically, everybody criticizes them. They've been banned from Mexico, which maybe they're really happy about. Luckily, the work that they're doing is not going to have a big impact, but it's an example of, I think, how simple it is to do compared to the infrastructure that you need for carbon dioxide removal. But these are the crucial questions for any solar geoengineering project. And there's a really strong agreement, even among advocates for solar geoengineering research, that funding should not come from fossil fuel companies, that funding sources should be completely transparent, that research should be transparent, and ideally, unlike carbon dioxide removal, which is really being taken forward by the private sector, there's a real desire that this research takes place within academic settings rather than through startup companies. One person that I spoke to from this organization, the Alliance for Just Deliberation of Solar Geoengineering, this is a nonprofit that is trying to foster public conversations about it, specifically with people from marginalized or climate vulnerable communities. One of the people here said she felt that the funding sources of all solar geoengineering projects, like there were some that weren't entirely clear, and that she felt it was a really fertile area for journalism to dig into, and that there wasn't enough scrutiny of the field at this point. So that's also a starting point. It's also worth pointing out that this is a fact that often surprises people, that people in developing countries tend to be more in favor of solar geoengineering than people in developed countries. Also, people experiencing climate impacts tend to be more in favor, perhaps understandably, and there's a lot of crossover between these two pools of people. So making assumptions about what people are going to think about solar geoengineering is not great. There's actually research that goes and asks people in different areas of the world, what do you think of this? Under what conditions might you be interested? And oh, don't worry. Anyway, I'm going to talk about this more in a second. Let's talk about some ideas for how we cover these technologies. And this is accumulated from my own research and reading and social scientists and media scientists who study this. I'm really interested in what you think. Please contribute. I've just got a few more slides. So context is everything. I think it's not only me, but people who study this research I think it's really important to make sure that in stories about these technologies, we remind people that the most important thing is to reduce emissions, and that that's also more important in the short term, that none of these technologies replace the need for emissions reductions. Certainly my memory is really short. I think that if I wasn't reporting on this field, I would easily become confused about all of these different sort of purposes. And if we do that, does that mean that we don't, if we remove carbon dioxide, it sounds like we're not going to need to reduce emissions, right? And to make sure that that context sits there within each story that you're writing about it. Secondly, the language we use is really important. We've got a really outsized power to influence how people think about these technologies by the language that we choose to describe them with. So a lot of social science research shows that if you describe something as natural, people like it. And if you describe it in sort of industrial terms, people don't like it so much. So, for example, with solar geoengineering, I could describe it as being, it's just like a volcanic eruption. Or I could say, well, imagine hundreds of planes a day taking off and spraying tiny sulfur dioxide particles into the air like contrails. One is a lot more appealing than the other, I think. Or with the big direct air capture facility that I showed you earlier, I can say it works like a tree, which it does. It sucks carbon dioxide out of the air. Or I can describe it as this giant industrial facility, more like a factory than a tree, which is correct. So social scientists recommend that we avoid the nature framing entirely because it introduces such bias. We can't help liking things that are natural, and that we do attempt to describe things as they really are and take a lot of care in the way that we describe things. I think another important point is that it's not just about the technologies themselves. The technologies are not intrinsically good or bad, but a project becomes appropriate or inappropriate depending on the social context. And research finds that when you ask people what they think about carbon dioxide removal projects or solar geoengineering projects, they're in favor or not in favor, depending on things like who's funding it, who's in charge of it, who gets to make decisions, does my voice get to be heard in it, who bears the downsides versus who profits from it. So I think it's really important to communicate these conditions to people, because it's not really possible. It becomes very difficult to have an opinion about the technology without the context in which it's going to take place. if there's a project that's hoping to operate in a particular location, asking how much interaction they've had with the community where they're hoping to operate is a pretty good place to start. And then the last one, and this is probably the most difficult one, is to correctly depict the risks of a project. And this is, I think, journalism on the highest difficulty mode because it's really hard to explain risks. And I think this is really at the crux of how we can contribute to the public conversation around this is to put risks in proportion. And the key is to place them alongside other risks so that people can see what size they are. So going back to the St. Ives project I talked about right at the start, the risk there was really, 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 really small because the amounts of the chemical being used was so small. But that's never really seemed to get communicated. And so people weren't given the opportunity to understand the size of the risk that they were facing. And they also didn't get that from an independent person, which didn't help. But the researchers I spoke to also thought that it's important to point out the counterfactuals of any project or technology. And I think this is particularly crucial for solar geoengineering, where the downsides are particularly high, potential ecological disaster if you mess it up. But the risks of not doing it also might end up being very high, like potential ecological disaster caused by climate change if you don't do it. And I think it's important to have those side by side. And in the debate about whether the projects should be used over the Arctic, there are people who've come out on both sides saying, no, we should consider these because the risk of not doing it and of surpassing tipping points in some of these polar ecosystems is really high. So we want to have this available if we need it, versus others being like, the risk of using these is really high. This is what I mean by you're sort of always trying to balance these risks up against each other and show people what exists. And it's important to point out, again, the counterfactual, what exists on the other side of a potential risk. And I think we're really important. I think that we're crucial to setting the scene for these conversations. The stakes are really high, and we can supply some scrutiny of these industries that doesn't necessarily exist. So my paper has this little sheet that has some questions that you can ask of projects on it and some principles if that's helpful. I would love to talk about all of this, so please get in touch if you would not like to chat right now. This is something I'm really interested in, but let me stop screen sharing and maybe we can talk about some questions.
Thanks so much, Rebekah. I do want to kick us off with a question that was submitted through the form, through the registration form. It sort of builds on what you just said about the balance of risks. The question was about evaluating the benefits and risk balance of these technologies. And it made me think of the fact that when you hear proponents, usually proponents of geoengineering specifically, talk about this, they insist that the risk-benefit balance is not the right one to look at. It's rather, like you said, the risk versus another risk of a non-intervention, right? So I'm curious what you make of this, and especially of the fact that even the language here, which, as you rightly said, the language is very important. Here, it's also a bit skewed towards, I mean, I know why the proponents of geoengineering want to talk about risk versus risk, because that's how you sway minds, right? So what is the right way for journalists to talk about this, even to ask the questions without falling into any particular traps uncovering this?
I think the risk versus risk is important to show. I think you need to show risks and benefits on both sides in order to be able to give someone the complete picture. But I think it's very hard to talk about these in the abstract without a location or context. So again, when you're talking solely about sort of ecological risk in general, because you're talking about potentially the entire world, unless you're talking about the form of solar geoengineering that's putting particles into the stratosphere that will affect the whole globe. I think it's better to talk about what specifically is contained within the location that you're planning to do it, what the region of the project is, and to look at something within a person's local context, because it's much easier to, for instance, the people in St. Ives to be able to ask, what's the risk to the seal colony? For instance, here's my local thing. What is the risks to my local environment? What are the potential benefits? What are the risks of not acting within this specific context? And I think that brings it down to earth a little bit.
Thanks. As we're still waiting for questions, maybe someone is probably typing as I usually do. I wanted to ask you something about the paper, right? Where you say that climate repair is not an ideal term for this tech, in part because it's also used by the industry, right?
Yeah.
Let's say. While you were working on this, while you have been looking into this topic, have you come across any, better attempts at calling this? Do you have a sense that there is one perfect,
It's
maybe, just good enough term for this?
It's really hard when you're talking about these two things together, carbon dioxide removal and solar geoengineering. It's much easier. Mostly we'll end up covering these industries completely separately. And so you can just talk about carbon dioxide removal, which is much easier. But I've actually, since writing the paper, which has got climate repair in the title, I think that I'm a fan of climate intervention because some of them sound too like climate repair sounds too nice, and it feels like it doesn't acknowledge how big the infrastructure is going to be needed for some of these technologies. One climate scientist who says this often is sort of like, if we're serious about carbon dioxide removal, it's going to become one of the biggest industries the world has ever seen. It's going to be on parallel with the cement industry. It's going to be huge and very industrial. And I think that climate repair just sounds too woolly. But then climate engineering, the word geoengineering, it has a lot of links to conspiracist thinking in some circles. And so I sort of want to avoid that as well. Solar geoengineering has a really big problem of being associated with the conspiracy theories to do with chemtrails in the sky. So no, I prefer to talk about the specific technology or industry whenever I can, rather than these overarching terms.
Great, thank you. We have a question in the chat on the actual position of the IPCC on this, which I guess is the communication, right? How does the IPCC and maybe, how does the IPCC talk about these different technologies? And my follow-up is, have you seen or heard any particular organization or scientists talk really well about this in terms of the things that you pointed out for journalists, right?
In terms of, let me talk about the first one, and then I'll ask a clarifying question about the second. The IPCC is unhelpfully vague at this point. It just says we're going to have to do some carbon dioxide removal to meet these pathways. And it says about solar geoengineering, it says, we don't know about this. This is an optional thing. It's not necessary. It's not going to sort out climate change. It's untested. We don't know enough. We don't regard this as a mechanism for meeting any of our goals. So it's pretty firm against solar geoengineering as part of a climate change solutions plan. And is there more about CDR in its, not that I know of. It's been a while since I looked through the 2022 report, other than it doesn't mention specific technologies, but it does mention that we will need, I believe it does mention that we need novel methods, not just the conventional ones. In terms of scientists that are talking about specifically journalistic coverage, do you mean? Rob Bellamy at the University of Manchester is studying this in particular, and he's written a number of papers about responsible communication of CDR that I've drawn from in my paper. Also, William Lamb is working on an analysis of whether, who is at a university, Mercator in Berlin, I think, is working on an analysis of whether or not media is communicating responsibly about this. So there's different scientists that have developed different frameworks for assessing journalistic coverage.
Thank you. I think it's worth maybe pointing out that the IPCC has a report on CDR coming out, I believe in 2027 it is scheduled. It's a little tricky because it's technically a methodology report, so it's not, I imagine, aimed at the widest publics, but it is on their agenda, so we'll see how the language around CDR evolves in that report. We have another question about, would you please speak about any international organizations that may exist who are monitoring companies doing carbon removal? What is the closest thing to an organization policing carbon removal claims? How is the scientific evidence behind carbon removal tracked or fact-checked?
I wish there was an organization policing carbon removal claims. It would be really great if I don't know, some government, international governing body could set one up. What there tends to be is nonprofits working within the particular sectors of carbon removal that look at their particular methods. So I think there's one that looks at ocean-based carbon removal methods specifically. And the sort of monitoring that you're talking about, I would look for a nonprofit that is an MRV nonprofit. So how I talked about that, like the carbon standards, the Carbon Removal Standards Initiative, those the people who work for those have really good oversight of the particular industry. But also the industry is it's still so small that there's a lot of gossip behind the scenes, and many people in it have a pretty clear idea of who is maybe overblowing their claims a bit and who is legit. They often don't want to say so on the record because these are their colleagues and they move in the same circles. But there's a lot of discussion behind the scenes about what is looking solid and what is not. So as soon as you start talking to people in the field, you tend to start finding this stuff out. How is the scientific evidence behind carbon removal tracked, fact-checked? It just exists in the body of literature. And I think there are now, I'm trying to remember whether I've actually seen a systemic analysis of carbon removal methods. The best place to start is the State of CDR report that I told you about. I'd say that that's the only big global tracker, and the authors of that are really good science communicators. You can also go and talk to that. It's published by Oxford University Smith School, I believe. So it's a good place to start.
Thanks. Well, I guess we'll give people a bit more time to ask any further questions. I wanted to follow up on the scientific evidence behind carbon removal. It is my very personal experience that startups that are doing this are all, like, I mean, they present themselves as all like tech heavy, science heavy, shiny, clearly, benefiting from the positive image of science and progress that will save the world. But technically, when you actually go into the weeds, it's often hard to see that evidence and how it connects to the size of the land we have available, right? So it's almost as if you have startups on one side and the science, the knowledge base, which is in the academic literature, on the other side, and there's a bit of a gap in there, which incidentally leads to, I believe, a lot of reporting on CDR is actually done by business journalists rather, or maybe tech journalists rather than science journalists. I was curious to hear your take on this and whether science journalists should be looking elsewhere potentially, not just into the literature, which is what we're used to, right? We're used to reading papers. What else could be useful in terms of this of reporting this responsibly?
Great question. I've just remembered I think there's a nonprofit called Seaworthy that is the one that is assessing ocean-based carbon dioxide removal methods. I think it's that, the letter C and then Worthy. This is a really great question. And the reason that carbon dioxide removal in particular has ended up being so corporate as opposed to academic is because academia was so slow off the mark. And so many of these early companies are staffed by scientists who left academia, climate scientists who left academia because they were really worried that nothing was being done and they wanted to try and take some action. The company that I talked about at the very start in St. Ives, their chief scientist is a guy who worked in Alaska for a bunch of field seasons, thought, oh no, I have young children, I need to do something, and realized that there was the only people pushing carbon removal forward were these startup companies. There wasn't an academic backing. And so sometimes what happens when there isn't evidence, it's because nobody has sought to create the evidence yet. And it's actually the company rather than any academic any scientist based in academia that is seeking to create that evidence. Ideally, and what the company at the start has started doing is to partner with a university and to try and move that forward. But in the early stages when an idea is super new and there are still new ideas popping up, like there's an idea to deflect sunlight by making lots of foam on the surface of the ocean, which is really new. Um, the best thing to do that I have found, and I'm interested in your ideas, is to talk to other scientists in the field who are really aware of the research and work on other parallel forms of carbon dioxide removal, because they are the world experts. The world experts are a bunch of sort of maybe 10 people, and they will all have different opinions about whether this thing works, what the sort of preconditions are, what the limitations are, and to try and create your own picture of it through the kinds of experts who would be commenting on academic articles if they were being published.
Great, thanks. I can see people sharing other resources in the chat, which is great. And I mean, by all means, keep doing this.
That was really good. Yeah.
I am going to ask you a trick question at the end, which is, I mean, it's good. You're going to start your day with a trick question. What is the biggest climate repair, shall we say, story next year that you're looking forward to, like that is on your radar? Maybe not the one you're going to pitch, because it's, you know, it's going to be published for journalists to watch.
Like something to watch, like something that's going to
Yeah, like
unfold.
something that makes you curious and just like maybe excited, not necessarily in a good way, but worried.
Okay, so there's just been in the last month, there's the first ever company that is doing solar geoengineering. And up until now, the very limited research has been in universities because everybody's worried about it. And now there is a startup called Stardust that has raised 60 million American dollars. And they have a secret particle that they want to use that everybody who studies this field is very skeptical of. They're like, we don't think that your particle is going to be very good, but we don't know until you tell us. And just the idea that that this might be a corporate thing rather than something that exists within this more neutral space is pretty worrying to me. And I'm interested to see what happens with that company and how whether it spurs whether there's like a boom in startups. The other thing that is maybe more fun is there's a company that's exploring the idea. They actually got funding from the UK's ARIA program. There's a company that's exploring the idea of putting a giant umbrella in space to protect the Earth. It's called the Planetary Sunshade Foundation, and it's a real thing. It's based in California because where else would it be based? And it will be interesting to follow that and see if that idea gains any traction, because I try and remind myself that so many of these ideas were super science fictional to start with, and now they're becoming real. So yeah, it'll be interesting to watch.
Yeah, I guess, you know, it's an interesting time for all of us. Well, most of all journalists. My final question to you, and this is last call for questions to be typed into the chat, or please raise your hand if you want me to ask you to unmute. Throughout your presentation, I kept thinking back to what my family knows about CDR or climate repair or geoengineering. And I feel that the gap between not just what the industry is saying, how they're talking about this, but even between the journalism and the best examples of journalism on this and the non-scientists, non-journalists understanding of how this might work is so large. I mean, what are your thoughts on this, and what is the responsibility here, perhaps? I guess,
I think, yeah,
yeah, go
sorry.
ahead.
You.
I'm not going to start your answer for you.
Well, I think the problem is there's different levels of journalism, right? There's journalism that's sort of talking to other experts and people in the industry, and then there's general public journalism. And I feel like there's not a lot of reporting on this in the general public level. And when there is, it's quite high level. And I'm not quite sure what that is. I wonder if it's an example of like we need to be able to speak to talk to people in the industry. You know, I end up adopting all of these acronyms, and I don't always remember to take them all out again when I'm reporting. And I wonder if there's just we don't have always the right radar for how much language needs to be simplified when you're in this environment and talking to people who are experts in their fields. But my motto is that nobody ever said that something was too easy to understand. And I try and remember that when I'm writing for a general public audience, because I think we can simplify or make things way more straightforward than they are. And maybe that poses a risk to almost I know that when I do that, I worry that my experts that I've talked to are going to think that I'm really dumb because I've phrased things in such a straightforward and basic way. But I actually think it's really important to do, and that's an impulse I keep fighting against.
Thanks. I think that's a great motto for science journalism overall. I'm going to second a comment someone made in the chat about this being a fascinating presentation, Rebekah. Thanks so much for joining us today. Loads to think about for everyone. The recording of this webinar will be posted on the EFSJ website. If you have any further questions, feel free to reach out. Rebekah's slides will also be attached to that recording. So, and obviously, do check out her paper on the Reuters Institute website. I've dropped the link into the chat, and I'll do it again just in case you missed it in the early history of the chat. Right, it's here. Thanks again, everyone. Thanks for joining us, and see you in the next events on technological solutions to climate change and how to report on them responsibly as science journalists. Thanks, everyone.
Thank you.